See, in previous video, we have proved that every convergent sequence is Cauchy. So see, now in this video, we are going to prove that every Cauchy sequence need not be convergent in a matrix space XD. Okay, so we will prove this remark by giving one counter example. So what will I do? I am considering let x is equal to open interval 0, 2. Okay, with distance d is equal to d of xy is equal to mod x minus y. So you know that this is a usual distance in R. So we have fixed our metric space. Okay. After that, I am going to take one sequence. Let xn is equal to 1 by n. So I am considering a sequence xn is equal to 1 by n. You are familiar with this sequence. This sequence has terms 1, 1 by 2, 1 by 3, 1 by 4 and so on. Okay. So now we are going to prove, yes, this is a Cauchy sequence but not convergent in a given matrix space XD. See, now we will prove that Xn is a Cauchy sequence. Xn is a Cauchy sequence. Okay. So using definition, obviously we are going to prove. So let us take one epsilon first. Let epsilon greater than 0 be given. Okay. So see what we have to prove. I am going to consider d of xn. See, we have to prove that this is less than epsilon. But see, first we will work on it. We will find its value and then we will prove that it is less than epsilon. So this is equal to, this is your usual matrix. So mod xn minus xn. This is equal to mod. What is my xn? Xn is 1 by n minus xm 1 by m. So you know that this inequality, this is less than or equal to mod 1 by n plus mod 1 by m. But see, n and m, these are two natural numbers, so they cannot be negative. So there is no need of mod. So that's why we can write this is equal to 1 by n plus 1 by m. So very important this inequality we have got here. I will call it as 1. See, after that I am going to use Archimedean property. By Archimedean property. Are you familiar with Archimedean property? This property says there exists a natural number greater than given real number. So therefore, there exists, I can write natural number such that which is greater than 2 upon epsilon. Okay, so natural, we can obviously get a natural number greater than this any real number. So I am taking a real number 2 upon epsilon. See, there is no more space to write. So make a screenshot of it first, then we will go further. See, I have kept this part here since we are going to use it later. Okay, let us continue. So what will I do? I will shift n on this side. So therefore 2 by n less than epsilon. Okay, so this is also very important inequality we have got. I am calling it as 2. For n comma m greater than or equal to capital N. So you know that in definition of Cauchy sequence, we write this thing at the end. Okay, so I am considering that part also. If you take reciprocal, inequality will get changed, right? So therefore 1 upon n plus 1 upon m, I am adding. So this one is less than 1 by n, this one is also less than 1 by n. So if you add, so this is less than 1 by n plus 1 by n, which is equal to 2 by n. So this is inequality number 3. So let us combine from 1, 2 and 3. What will you get? We'll start with from there d of xn comma xn. See, this is less than or equal to 1 by n plus 1 by m. 1 by n plus 1 by m less than or equal to 2 by capital N, and 2 by capital N is less than epsilon. So finally we can write this is less than epsilon for all n m greater than or equal to capital N. Okay, so simply I use this logic: a less than b, b less than c, c less than d, then a less than d. Okay, so I combine all these inequalities. So this is not required now, so let me remove it. Okay, so we have used this part. Let me remove this part and we will continue. Okay, just a minute. Yes. So therefore, this is a definition of Cauchy sequence. Therefore, what can we write? Therefore, sequence xn is Cauchy in xd. So therefore, sequence xn is Cauchy in xd. And sequence xn means 1 by n, which converges to 0. Getting? In our previous video already we have completed, we have discussed the proof of it. You can watch that video. So here I am writing directly. So this sequence 1 by n converges to 0. But see, 0 does not belongs to open interval 0 comma 2. What is a capital X? What is a metric we have considered? What is a set we have considered? Open interval 0 comma 2. This sequence converges to 0, but this is open interval, so therefore it does not contain its boundary points. So 0 is not a member of that set. So therefore 0 does not belongs to X. So therefore sequence xn is not convergent in xd. Getting? That means we are having a sequence which is Cauchy in xd but not convergent in xd. Therefore every Cauchy sequence in xd need not be convergent. So in this way we completed proof of this remark. Okay, so make a screenshot of it, then we'll stop. Thank you. Bye bye.